Hello everyone. Now I'm back with further part of trigonometry. Now some of you must be wondering after last session that if I have forgotten about remaining trigonometric functions. My entire time and energy actually were spent only on explaining that what we mean by cos theta and what we mean by sin theta. And I'm sure those who have listened to that particular session, they must be wondering that not even in their dream they had ever thought that sin theta and cos theta anyone would describe like what we have seen in our last session. Because you were just restricted to that right triangle in your previous classes. Now you must have understood that we will have to expand our boundaries and you have to go further and further and further. Now, first thing what you must have observed is that in your previous classes, you were taking angle as some number, tan 30 degree or cos 30 degree, something like that you were taking. Now, suddenly I started in my last session that I will be taking theta as some real number. And we spoke and spoke about cos theta and sin theta, theta belonging to R. That was not at all a treatment given to sine and cosine in your previous classes. So please revise that particular session and then listen to this session. This is my advice to you. Now in this session, we will be starting with other trigonometric ratios, or instead of saying ratios, I will call it now functions. Why I am calling function? Because now I am taking theta as a variable. So first trigonometric quantity, what you think could be tan theta. And you have written previously also tan theta as sin theta upon cos theta. And also remember that place where cos theta has appeared in the denominator, and that was nothing but sec theta. So sec theta is 1 upon cos theta and tan theta is sin theta upon cos theta. Denominator has cos theta in it. So cos theta cannot be 0. Now where cos theta had become 0? Recall your that unit circle what you had seen in our last session. Now positions q and q dash in that unit circle, there you had seen those were the positions which were on y axis, and hence those two positions had x coordinate 0, means corresponding cos was 0. And what were those angles at those two positions q and q dash? They were 2n pi plus pi by 2 or 2n pi minus pi by 2. At these two positions cos theta is 0, and hence tan theta and sec theta will not remain defined for certain values of theta. And what are those values of theta? They are 2n pi plus minus pi by 2. Also, that 2n pi plus minus pi by 2, if you wish, you can write in one statement, and that is 2n plus 1 into pi by 2. That means 2n plus 1 is an odd number. I hope you understand that. N multiplied to 2 means it would be an even number. 2n is an even number. You add 1 to it, it will become an odd number. So 2n plus 1 into pi by 2 means odd multiple of pi by 2. And that odd multiple of pi by 2, position q was pi by 2, then q dash 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2. So they are all odd numbers. So odd multiple of pi by 2, if you are taking positions q and q dash of that unit circle together, that would lead to theta not equal to 2n plus 1. That means odd number multiplied to pi by 2. So here onwards, tan theta and sec theta may not be defined for certain values of theta, which you had not thought in your previous classes. Now, this gives you a hint that we have to revisit now cot theta and cosec theta. So let me define cot theta. Cot theta is cos theta upon sin theta, like previous, like what you have done. Cosec theta is 1 upon sin theta. Again here, in denominator, sin theta is appearing, and sin theta means y coordinate, means positions p and p dash of unit circle, where sin theta was 0 because y coordinate was 0. So positions p and p dash correspond to what? Even multiple of pi and odd multiple of pi. Neither even multiple of pi allowed nor odd multiple of pi allowed. Means what? No multiple of pi allowed. So theta not equal to n pi, where n belongs to z. Z means set of integers. I hope you remember previous sessions of set theory also. There we have used the same notation. Now, I move further and I use those trigonometric identities which you have already done. You must be missing them all this time, right? So trigonometric identities. What was first one? Sin square theta plus cos square theta equal to 1. Now here also we have that same identity. Sin square theta plus cos square theta equal to 1. Additional thing what I am writing here is theta belongs to R. is there is no theta which could be troublesome to us. Now, be careful when you write next one. That is 1 plus tan square theta equal to sec square theta. And sec square theta means sec theta is involved. Tan square theta means tan theta is involved. And see at the top, sec theta and tan theta not defined for odd multiple of pi by 2. So, theta not equal to odd multiple of pi by 2. That was obvious. Now, similarly, write one more. That is 1 plus cot square theta equal to cosec square theta. Again, see at the top, theta not equal to n pi. So, theta not equal to n pi, we will have to write here also. Now, what we have done is that we have just rearranged, or rather I should say redefined those trigonometric identities with some additional corrections which you should not forget here onwards. Now, let us proceed with this much background further. And that is that I will have to see now that by now we have defined all sine, cos, tan and sec, cosec, cot. Now, we will have to define what are their domain and range. Now, domain and range, these two words are not new to you. Mind you, please, we have already done this in functions. Now, let us define them one by one. Now, first function could be my sine theta. And for that, domain is R, because you can take angle, anything. Any means any real number you can substitute there. And sine values were between -1 and 1. And hence, range is -1 to 1. Next one is cosine theta. Again, you can take angle, any real number. So, domain is R, that is set of real values. And range is -1 to 1, closed interval. I hope you understand why do I say so. Because cos theta was always between -1 and 1. Mind you, please, -1 and 1 inclusive. And hence, the square brackets. Those brackets are also important. Please do not forget them. Don't write round brackets. Now, next is tan theta. Now, theta not equal to odd multiple of pi by 2, we will have to write. So, domain is all real values except odd multiple of pi by 2. Means they will have to be deducted from there. And what about values of tan theta? Tan theta can take any real value. And hence, range is capital R. Now, go for their reciprocals. Now, first is cosec theta. Now, when you say cosec theta, mind you please, since sine theta was between -1 and 1, so cosec theta will not take values between -1 and 1. Why? Because it's reciprocal. And also, cosec theta is 1 upon sine theta, and sine theta becomes 0 for any multiple of pi. So, we have removed any multiple of pi from set of real numbers in writing the domain part. And range R minus open interval -1 to 1. Cosec theta can take values -1 and 1. Mind you please, and that is why now I have written round brackets there. Because we are not going to remove -1 and 1. When does, by the way, cosec theta become -1 or +1? Whenever sine theta becomes -1 or +1. Because it's reciprocal. Now I go to next, and that is sec theta. Now, do I need to tell again why R minus open interval -1 to 1? I think that part is clear to you. But sec theta has cos theta in its denominator, and hence odd multiple of pi by 2 are removed from the set of real numbers to define domain. And now one more, last one, and that is cot theta. Again, cot theta has sine theta in its denominator. So in the domain part, we will have to remove any multiple of pi because there sine theta becomes 0. And as far as values of cot theta are concerned, cot theta can take any real value. Hence, range is set of real numbers. If you remember domain and range of these trigonometric functions, it would be helpful from problem solving point of view in future. That is why I have taken them here separately. Try to, I will not say mug them up, but try to remember them. I mean, they have to be in your mind when you start solving problems. Now, please revise previous session and this session. I mean, keep practicing, keep revising all the time, especially trigonometry in radians and in terms of unit circle. Revise them and then meet me in the next session. Till then, stay tuned. Thank you.